I'm going to show how to use APL's array notation. The notation is pretty intuitive for matrices. We use square brackets and can simply write each row of the matrix on separate lines. For vectors, we use round parentheses. Just like with any other APL code, we can use new lines or diamonds interchangeably. We can tell APL to output using the array notation as well. We can toggle it using this button. And we can see how it formats the vector of vectors as a 2D representation using the array notation. This is especially useful for namespaces, which we write also using round parentheses and name value pairs. A name, then a colon, and then the value. And the output form shows each member on its own line. We can also write an empty namespace just as an empty open parenthesis, close parenthesis. We can initialize a variable without giving it a value first, directly into array notation input mode. Here we have a window with new array notation. There is nothing here yet. And we can start typing our array notation right away. We can also use any APL expression directly inside the array notation. So here, where I'm inputting a matrix, and I know that the next row is going to be 1, 2, 3, I can just write that as iota 3. I can then ask APL to reformat this in the standardized form. On the menu, we've got reformat, and there's also a keyboard shortcut for this that I'll be using going forward. Here's the normalized form, and we can see the iota 3 was expanded. Okay, let's close and save this. Now we can output foo, but the output isn't just an array notation representation of this. It's actually a value, code that we can go and work with. So let's flip this horizontally. Of course, it's strange to work with APL input at the left margin. Normally it would be indented. In the menu we've got reformat, and the keyboard shortcut also works. And this doesn't evaluate anything yet. It just reformats the code with the indentation, etc. Here, pressing enter, we get the new matrix. We can also use other forms of text editing to change the value. So here I use a right click and drag to do rectangular selection, and I can delete this column and press enter, or we can reformat it first and then press enter. Whether a variable exists already or not, if I have the text caret on its name, I can click the Edit with Array Notation button to open it up directly in the editor. If I edit it in the normal way, I can switch between the normal editor and the Array Notation editor using this button. And there's also the keystroke for edit, which I can just use again. I don't have to work with what's already there. I can just remove everything and write an APL expression. And now reformat will evaluate the expression and give me the array notation for it. We can switch back and forth between the array notation mode and just text mode. Here we can see that it is a character array, a matrix. Let's take this matrix and make it into a flat vector by adding new lines to it and raveling it. I'm now going to reformat it. We can switch again to the text mode and see that says here it's a modified character vector. Let's switch back again. Now let's try going back to a character matrix. We can use quad_fmt for that and reformat. Oh, this gave us a lot of spaces. So let's go and split this matrix into a vector of vectors. We can see how the brackets changed into parentheses to indicate that this is a vector of vectors. Now we can remove the space from each one and reformat. And finally, we can go and mix it into a matrix. There's also an extra line there that we don't need, so we'll just use normal text editing to remove that. Good, we've got our character matrix foo. Let's turn off the array notation as output, and we get our normal output of this matrix. We can also use the array notation inside code, inside any other function definition. So here we use the stencil operator, which takes a right operand that can be a matrix. A two-row matrix, the first row indicates the window size. We're going to have windows with 2 rows and 2 columns. And the second row indicates the step size. So we're going to do a step size of 1 vertically, but a step size of 2 horizontally. And so this is conceptually a single line of code that begins over here, but then spans multiple lines and continues over here where we have got some array notation in the middle. And I've added the spaces so that it looks nice, but of course I don't have to do that. And you can use the array notation inside any type of function. Here it was tacit. We can use it inside defins and transfins as well, and indeed anywhere where you would put an array value where you can have multiple lines of code.